Hello everyone. Today we will conduct a comprehensive hydraulic system performance test inside the laboratory. The purpose is to familiarize you with the behavior, characteristics, and responses of a standard hydraulic system. During this test, we will observe system pressure, flow rate, cylinder movement, response to load, and overall efficiency. Safety will be emphasized throughout the procedure, as hydraulic systems operate under high pressure and can pose significant risks. Before we begin, ensure each participant wears required personal protective equipment, safety glasses, steel-toe footwear, gloves, and lab coats. Make sure any loose clothing or accessories are secured to prevent accidental entanglement with moving parts. Overview of the hydraulic system. Let us start by reviewing the main components of a hydraulic test bench. The system includes a fixed displacement hydraulic pump, pulling fluid from the reservoir and delivering it at a steady rate. A hydraulic oil reservoir, which holds the fluid and allows cooling, aeration, and filtration. A pressure relief valve, which acts as the primary safety device by limiting maximum system pressure. A directional control valve used to direct hydraulic fluid into different sides of the cylinder. A double-acting hydraulic cylinder, the actuator we will measure and observe. Pressure gauges installed at key points in the system to help monitor pressure changes. A flow meter, providing real-time flow rate data. A mechanical loading device that will allow us to apply controlled resistance to the cylinder. All these components form a closed-loop hydraulic system that converts mechanical energy into hydraulic energy, and then back into mechanical motion through the cylinder. Pre-operational safety checks. Before energizing the system, we must perform a full inspection. Please follow along as I explain each check. First, examine all hoses, fittings, and connectors for any visible signs of wear, cracks, or leaks. Even small leaks can compromise system performance and safety. Next, verify the reservoir is filled to the recommended level. With the appropriate hydraulic oil, insufficient fluid leads to cavitation, poor lubrication, and pump damage. After that, check the power supply and ensure that the emergency shutoff button is functioning properly. Confirm that the pressure relief valve is set to a low pressure. This prevents unexpected spikes when the system starts up. Also, check that the directional control valve is in its neutral position. Finally, make sure the mechanical load device is disengaged so the cylinder is not under load during system startup. Once all safety checks are complete, we may proceed to the first stage of the experiment. Stage 1. System activation and no-load testing. Everyone stand clear of the moving components. I will now switch on the hydraulic pump. Observe initial readings on the pressure gauge. Under no load, pressure should remain low, typically between 10 to 20 bars. Using the directional control valve, I will extend the hydraulic cylinder. Watch its movement carefully. Under no load, the cylinder should move smoothly, without hesitation, vibration, or unusual noise. Note the flow rate on the flow meter. It should be at its highest value now. As the cylinder reaches full extension, I will reverse flow and retract it. Pressure remains stable, motion smooth. This confirms the system is primed, free of air pockets, and mechanically sound. Once no-load movement is verified, we stop the cylinder mid-stroke and record baseline data. This includes no-load pressure, flow rate, and speed. These establish a reference for mechanical loading. Stage 2. Applying medium load. We will apply moderate mechanical load using the adjustable loading system. This simulates real-world conditions. Increase load until the cylinder requires higher pressure to move. With load applied, I'll extend the cylinder. Pressure gauge now climbs higher, between 40 and 80 bars. The flow rate may show a slight drop due to increased resistance. Cylinder speed may also reduce. Record these data points: operating pressure, flow rate, cylinder speed, and movement behavior. Pay attention to any unusual sounds like rattling, cavitation, or vibration. These could indicate issues like pump strain, trapped air, or internal wear. Now, retract the cylinder under the same load. Observe and document any pressure differences. This stage demonstrates system behavior under intermediate working conditions, evaluating efficiency and stability. Stage 3. High load and maximum pressure testing. This stage must be done slowly and carefully. The system will approach its maximum safe operating limit. Gradually increase the mechanical load. As I extend the cylinder under high load, Observe how the pressure gauge rises. Eventually, the pressure relief valve will activate, maintaining pressure at a predetermined limit. When the relief valve opens, you may hear a slight change in sound. Cylinder movement may slow dramatically or stop entirely. Load has exceeded system's ability. The relief valve keeps the system safe by preventing further pressure buildup. Record the maximum pressure reading and note if the relief valve activates smoothly. A smoothly functioning valve indicates a healthy safety mechanism. Jerky or inconsistent behavior may suggest contamination or repeat the process for the retraction stroke and document any differences. Once all readings are taken, gradually reduce the load back to zero. System shutdown procedure. Now that the testing sequence is complete, we can begin the shutdown process. First, return the directional control valve to neutral. Turn off the hydraulic pump and allow the system to depressurize fully. Verify that the pressure gauge reads zero before approaching the equipment. Inspect the hydraulic hoses and components once more for any signs of stress, leaks, or overheating. Allow the system to cool if necessary before disconnecting or resetting anything. Clean any oil drips or spills to maintain a safe laboratory environment. At this point, we will review the data collected during the no-load, medium-load, and high-load tests. Compare the changes in pressure, flow rate, and cylinder speed between each stage. You should be able to see a clear relationship. As load increases, pressure rises, while flow rate and speed tend to decrease. Additionally, evaluate whether the system behaved consistently. Look for any abnormalities, such as fluctuating pressure, slow response, excessive heat buildup, strange noises, or jerky cylinder movement. Any of these could indicate system issues like pump wear, internal leakage, or air in the hydraulic lines. Finally, verify that the relief valve activated at the proper pressure. This is one of the most important safety features of any hydraulic system. This test has allowed us to examine the hydraulic system's behavior under a range of conditions. By carefully recording and analyzing data, we can assess the system's operational health, efficiency, and stability. Understanding these principles is essential for anyone working with hydraulic machinery, ensuring reliable performance in real-world applications. Safety and reliability first.